Thank you for joining us, everybody. My name is Wolf Rendall. I'm the Director of Data Products at Vontive. I'm going to be walking you through sort of the business case for how we've adapted DBT and Materialize to underwrite mortgage loans for investors in real time. So let me first give you a little bit of background on what Vontive is. So Vontive, white label investor purpose mortgage origination software. What does that mean? There's about 5,000 different smaller companies across the country that offer these kinds of investor purpose mortgages, and a lot of them would prefer not to have like in-house underwriting or capital markets partners, things like that. So for them, we offer a way to basically outsource all of that. Deals come into our platform, we underwrite them, we fulfill them, and if we do our jobs right, nobody really knows that we were involved. Data products, what do we do? Basically, credit policy tools, underwriting tools, business intelligence, economics research, all the things that you would think of when you think of data nerds. And so Vontive has about 25 different products when you consider all the different options: short-term loans, long-term loans, loans with construction, loans that don't have construction. And we have different credit policies for each one of these, and they're a little bit different for each one. So this is really difficult for human underwriters to sort of keep all the rules straight. When a loan comes to us from a partner platform, that kicks off a process where about 40 different data sets start their completion process. And I've got two different examples here of different loans that do and do not meet the credit policy. So first of all, we have two similar loan amounts, 500K, 500K. One has an appraisal, appraised value 600K. The other one has appraised value 550K. Both of them have insurance coverage, 320 versus 400. However, one important difference is that the appraisal for one listed a replacement cost of $300,000. The appraisal for the other one listed no replacement cost at all. It was a different format, different appraisal company. Sometimes it's available, sometimes it's not. The credit policy states that you need to have insurance that covers at least the amount that it costs to replace the building if it should be destroyed somehow. So the second one, because even though it has more coverage than the other loan, there's no replacement cost given. It doesn't meet the credit policy, so it's no good. This is one of many, many examples of interlocking conditions that our loans have to meet to sort of make it through the process. What happens when a loan mistakenly gets through the process? It's actually really bad. We can have failed sales, we can be forced to repurchase the loan, we can have a bad experience for the borrower. It can be terrible. So to mitigate this, we built a system for validating these data sets as they come in. Data comes in as it wants to. The offer can change up to the close date, new appraisals can come in, the insurance can be different, the entity formation documents can come in late. All these things can change the ratios in one part of the loan. And the difference is the underwriter may have checked this on Monday, and then on Tuesday, a new data set comes in, and it's different than what they thought it was going to be. The ratio is no longer valid. It's very, very frustrating. Oh. So what we did in this system, basically, is we started with DBT, we built a data warehouse, and started building views to check all these things. The checks that we built are pretty simple. SQL query checks amongst all these different data sets. Is the insurance coverage greater than the replacement cost if it's available, yes or no? We built 25 of these to start, and we got a lot of really good traction. Insurance is where I'm going to start because it's one of the most important things that we check throughout the whole process. After we started building these things, we put it onto the portal. Underwriters were sort of triggered by these alerts triggered, and underwriters could see in real time, oh, this value makes sense, this value doesn't make sense, it's in compliance, it's not in compliance. And their behavior changed. So let's take a look at that. So what you're seeing here is the red line represents the total number of edits that an insurance data set would undergo during the underwriting process. The blue line represents the total number of edits that would happen in the first week of that data set being created. And the green line is the ratio between the two. That little orange triangle tells you when we implemented the loan catch system that implemented all these validations. Once we implemented the validations, you can see that the number of the number of edits that these insurance documents, these insurance data sets would undergo in that first week shoots up from about 50% to about 80%. And then the purple triangle is when we brought in Materialize, because Unfortunately, or maybe as a victim of our own success, these checks became super, super popular. Every department wanted more. Every single interaction of all the data sets needed to be checked. We didn't want any failures at all. And so we kept building more and more checks. And then, unfortunately, we got to about 25 checks. And what did we find? Oh, the API gateway's timing out because we invented too many checks and they were taking too much compute time. And so here we are. We had to stop. We had to start a search, a quest, for how we could overcome this blockage. And this led us to Materialize. And so Materialize presented two really critical benefits for us. Number one, we could keep DBT. We could keep all of our code pretty much the same as it was. We just kind of had to point our system as it was, our development process, our deployment process, towards Materialize's endpoint. And then number two, it provided this incremental view maintenance that was really, really valuable for reducing the compute time. And with that, I'm delighted to hand things over to Stefan, who can walk you through the Materialize side. These are just SQL queries which return an alert. So we have these multiple interlocking conditions, and it's not necessarily about the data validation, like, oh, the type or like that. It's that the business logic needs to conform, and so the SQL query handles that. That's what I mean when I say check.
Cool. So the problem Wolf was facing is actually pretty common in the industry, right? And that's not a bad thing. It's just a consequence of how we build stuff. When you get started with a project, a relational database is just a very natural choice to put your data, right? And over time, you get curious, and want to learn from what's actually happening in your business. So you start running queries, analytical queries, against the database to get an idea of what's actually happening in the business. And the further you progress, the more complex those queries become. And at some point, things start to slow down. And that's usually where you introduce a read replica to segregate your production transactional traffic from your analytical queries. But that doesn't resolve this mismatch between the complex analytical nature of your queries and what relational databases are good at. So a natural step at this point is to offload the analytical queries into a data warehouse. So you use an ETL process to move the data from the database into the data warehouse, because data warehouses are really good at running these complicated analytical queries. But that doesn't come without trade-offs. When you're querying the read replica, you're operating on fresh data, but your queries may be slow. When you're using the data warehouse, the queries return fast, but now you're effectively operating on stale data because you can only move data from the database into a data warehouse so often. So Materialize has been built to resolve this kind of tension. It's an operational data store that has been built to transform, deliver, and act on fast-changing data by just using SQL. So with Materialize, you can break down data silos and join data across different data sources in one consistent and always up-to-date view. And with that, you can actually benefit from fast queries on fresh data without giving up on things like consistency or expressiveness of the queries you can run. And that's actually a pretty bold claim. So let's just take a look at how it actually works under the hood. So the first thing is that we can continuously load data from the upstream data sources. We connect directly to a replication slot of a database such as Postgres or MySQL and continuously pull in the change data into Materialize. We also support sources like Kafka, or you can make post requests against a webhook, and then data lands in Materialize. And once the data has been loaded, you can just run your models, build your models on top of that, as you would with any other database or data warehouse. And Materialize is not only fast because of this continuous data load, we also do incremental view maintenance under the hood. So we continuously keep your models up to date. So rather than doing work on read, when you issue a query against Materialize, we do work on write. So whenever the inputs of your queries change, we update the results of your models automatically in the background for you. So when a query is issued against Materialize, that doesn't really cause additional work, because we can just return the pre-computed results back to the client. And in this way, we can respond much faster to queries and support a much higher concurrency than other systems. And all this works while maintaining strong global consistency across all your data sources within Materialize. So you don't give up on strong consistency guarantees you use from databases. And because of the incremental nature of the computation, there are now two different ways how you can query Materialize. We are Postgres wire compatible, so you can just use run queries with any client that can talk to Postgres, and they can connect to Materialize. You can run queries through that. So we can connect your libraries, your client libraries, BI tools, and just point them to Materialize, and it works. And you start to benefit from these incremental transformations that are happening under the hood. But because we are doing work on write when things change in the inputs, we can also send out notification whenever there's a new result. So this is great for event-driven applications, or more generally for operational use cases where you want to act on things that are changing in your data. So we can send out notifications to Kafka or S3. You can also wrap any ad hoc query into a subscribe. And what that does is it essentially opens a long-standing connection, an infinite cursor if you want. And whenever there's an update to that query, whenever there's a new result to that query, we push that update to the client so that you can react to that. And one way to leverage that is to always keep your caches up to date, right? Whenever the data changes, you can use this notification to update your caches and avoid a lot of the cache invalidation problems you would be facing otherwise. So this is just a slide to give an idea of how customers are commonly using Materialize, patterns that we have seen. The first is query offload, and that's basically the pattern we have been discussing in the last few slides. So the idea really is to offload complex analytical queries to Materialize so that your primary database can still serve the transactional traffic and you benefit from fast reads for your analytical queries. The operational data store is then a natural evolution of that pattern, where instead of looking at a single data source, you combine the data from different upstream databases or data sources, and then join, enrich, and normalize the data so that it's readily available for the consumers to act on the data as it changes. And the last pattern is the operational data mesh pattern, which is a great way if you want to isolate different services from each other. So each service has their own data store and can use their own technology. And you can, with Materialize, retain the capability to join across these databases. So the idea is every service publishes a data product into Materialize, and that data product then is the interface on how they want to share data with other services. And you can then join the data within Materialize while the services remain fully isolated. And all this nicely integrates with dbt through our own dbt connector, right? So you can use dbt as you would with any other database or data warehouse. The difference is, we'll automatically keep your models up to date. So if you execute dbt run once and only once, and we keep the models up to date. So no more scheduled dbt runs, no complicated incremental models. You deploy your models, and we take care of the rest. And that means that you can also continue to use tests and CI/CD and adhere to software development best practices. And what's interesting here is that tests are evaluated incrementally as well. So you can get notified the moment a test fails to pass, rather than waiting for a report that's running at the middle of the night or something. And as usual, you can continue to use your standard workflows you're used to with dbt and benefit from the templating mechanism that comes with dbt. So with that, I hope I got you excited and sparked some ideas how you can use Materialize as an operational data store to address your operational use cases. And with that, I'm going to hand it back to Wolf, who's going to explain how they've been using Materialize to overcome their challenges.
Thank you, Stefan. Oh yeah, I'll take that. Is it this? We'll continue as is. So yeah, thank you, Stefan. Okay, so with all of these views running, incremental view maintenance, the work is done on write, not on read. Everything got way faster. We were no longer living in this 25-second query complete world for all of the different queries we were building out. And so we were free. We could start adding more queries. The backlog started to get worked through. We went from 25 to over 250, and we were still at 1 second read times no matter what we did. And then when we realized we were still so fast, no matter what we did, we started thinking, where else could we show the data product, right? So what I'm showing you here is where the data product for these data consistency checks, loan catch is what we internally call it, where it first showed up, which was on what we call the workbook. And so an individual operator is getting these alerts about, oh, you know, this is telling you that the hazard insurance provides no replacement cost and the loan amount is too high, those kinds of things. That was where it started, and then we started putting it into more workflows. So the same exact data, we were starting to query from more places. So you can see at the upper, or on the upper image, that's where the underwriter is actually entering the individual data fields after reading these documents. Sometimes they have to read a whole portfolio of documents to fill it in. But we started showing it there. We started showing it at offers. We started being context aware with what the user was doing and sort of showing them the proper alerts for when rules were starting to get broken. And so what do we get for this, right? The faster completion time, that's great, I think. We don't really know, right? So how can we connect that to dollars and cents? Who cares that the data set's completing faster? Well, now we're looking at more of like our entire business here. So what I'm showing you here is the average number of days from when a loan entered underwriting until it exited underwriting. And you can see we were kind of living in this like 15 to 20 day world. And then after implementing Materialize in this loan catch system, we're kind of consistently living in this 10 to 15 day world. And there's other reasons for that at the company for sure, but we can definitely see a step change from when we implemented this system versus before we had it. And what does that let us do? So when I showed you that original slide of, oh, we're catching a lot of errors in the insurance data sets earlier, a lot of our other data sets are now benefiting from this as well. This means that we're sort of, you know, we're looking at the total range of outcomes, we're looking at the unacceptable outcomes, and we're kind of guaranteeing that those don't happen. In 2023, we had about 51 failed loan sales because of these material differences, because of things that didn't, you know, tie out, right? We said the loan had this profile. Turns out, upon reviewing the documents, things had been missed. The loan actually has this other profile. And the loan buyer comes back to us and says, you didn't sell me what you told me you did. You have to buy this back, or I'm not buying that. Terrible outcome. In 2024, with loan catch implemented, expanded, and our partnership with Materialize, we've had 0 failed sales and 0 demands for repurchase for any of our loans. And so we've now kind of actually exhausted the ability for us to run checks on our data model, our data architecture as it exists today. So the way that we've constructed our data sets that hold all this information about entity formation and appraisals and all that stuff, we're checking all those fields now, and we're kind of at the end of our rope for what we can do without changing the human's workflow. We're gonna have to start asking for them to fill out more questions in the form for us to have even more coverage of even more complex interactions. That's going to be very expensive. So both from the cross-functional side of saying like this department has to talk to this department to figure out if this is something that we can do, we're actually starting to move into a different paradigm because we have this validation system in place and because calculation is so fast. We've recently developed an AI document parsing process. We use Claude Sonnet 3.5, but you could use a bunch of different ones. And so we send the AI the document portfolio that we would have normally sent a human, and then we send it a prompt saying, please fill out this data set based on what you can find from this set of documents. Prompt development's cheap and easy. Schema changes are cheap and easy. So this sounds really good, right? So what I'm showing you here is the way we're trying to think of further development with DBT, Materialize, and AI all going hand in hand, where we're now sending the portfolio of documents to Claude. Claude responds with both what he's extracted and his reasoning for why he extracted that. And then we have our system of validations running at the same time. Everything goes faster and faster, and humans no longer have to be involved in that first 80% of the process. They can focus on the harder cases where maybe the AI can't even extract anything, or more importantly, they can focus on just validating everything that has gone up from an automated perspective up to that point. So this is kind of how Materialize has kind of shaped our company's culture, I would say. So thank you very much. Do we still have time? Is there questions? Yeah, for sure. So one of the interesting parts about the current generation of LLM. Oh, yes, yes, yes. The gentleman had a question, does the LLM process have any sort of concerns, or would you see any concerns about the format being in the expected format that you saw here? Actually, LLMs, at least the ones that we're using, allow you to define a function, and then it can run the function on its own output. So you can just have a JSON extraction function, and it'll sort of run that at the end to give you the output that you're looking for. You could also run it yourself as a Lambda from the output. That's the most fun part of the loan underwriting procedure, I would say, is that data comes in when it does, right? So you may order an appraisal and you're expecting to get it in 2 weeks. Turns out it's available in 3 weeks, or maybe it's available in 10 days. Meanwhile, the loan officer has had a conversation with their borrower, and the borrower says, actually, I need not 70% loan to value, I actually need 90% loan to value. Can you get me that? Send me an offer, I want that. So the data changes daily, all the time, always. And it's very common, especially in the olden days before we had this system, that an underwriter would validate all the data on Monday, and then on Tuesday, something new would come in and wreck it. And so I don't really think we could even, it kind of makes sense we had so many failed sales, right? There's no way that a human could really keep track of that. And so what Materialize does is that work on right is the major thing, because it doesn't matter when the data comes in at that point. Yeah, sure. I think you're referring to the question was, we have wrong documents come in. I think what you might be referring to is sort of different format documents. I think you're referring to the appraisal that was missing the replacement cost. So as anybody who's working with sort of like property tech or fintech will know, every jurisdiction is a little bit different. Every company that you partner with has a little bit different format. This appraisal just didn't return, like that appraiser didn't evaluate it for the replacement cost. It wasn't part of their return. So it wasn't necessarily wrong. Appraisals are valid to come back with fewer fields than totally complete. But I would say Materialize helps us because we can now construct a policy that lets those deals move through if they're still meeting all the other criteria. But it wouldn't necessarily be a wrong document. It's just there's so many formats. There's 3,000 counties in the United States, there's probably 5 big appraisal companies, and so you're getting different formats for taxes and appraisal, and these formats all have to come together, and that's the data set construct that we're talking about when we sort of bring the data in. Go for it. Yeah, so we will receive approximately, I want to say 2,000 to 3,000 loan applications per month. And from that, we end up producing about like 200 funded loans per month. That's because we have a pretty restrictive credit policy, but loans go as far through the pipeline until we can find something that says, oh, I'm so sorry, you've broken an eligibility rule, we can't do this loan. So there's work done on a vast array of loans before we get to that like cream at the top. But that's approximately the scale, is about 3,000 submissions per month. Oh, that's a great question. By show of hands, who thinks that they have a data architecture that is over-regularized? Like way too many tables, way too many areas where have to know how to do the join to bring it all together. Yeah, well, that's definitely, I think I'm seeing maybe, I don't know, 20% of people. That's definitely the world that we live in. So we have probably 300 tables to express all of the loan documents. And so, if we're doing 200 loans a month with 300 tables to represent all the data, the Postgres fans out quite large in that case, but with all these sort of very small tables with lots of joinable keys. And I would not want to subject you to the ERD of what the topology looks like in there. Go for it.
So the way to think about this is we are really focusing on the operational aspects of your data landscape. So something where you want to react to changes quickly, you want the data to be available as quickly as possible. That's where we really fit in nicely. And it's not uncommon to find Materialize in front of a data warehouse. So we are good for these operational use cases, and then we age out data to the data warehouse for more long-term analytics. Right. Yes, exactly. Cool. Yeah. Like, do you mean like how you use DBT with Materialize? So like you just. Sorry? So the mechanics work as if you were using a common database, right? So you use the Materialize adapter and point your DBT project to Materialize, and then just deploy your models. And we're using Postgres SQL. So as long as your queries adhere to Postgres SQL, you can just deploy your models to Materialize, and we keep them up to date for you. So if you want to actually do something with the data, you can run ad hoc SQL queries against Materialize, again, as if you were querying a database. Or you can set up a sink that then sends out notification to Kafka, for instance, so that you can pick up these changes in a more event-driven environment. No, like you execute DBT once to deploy the model. So then the SQL definitions, the view definitions are part of the catalog of Materialize. And then the incremental processing is about the data that is flowing through the system. And we are doing incremental view maintenance. So we look at what row changed in the inputs and then only propagate those changes to adapt the outputs accordingly. Yeah. Exactly, right? So we, from the perspective of the database, we look like a read replica, right? We connect to a replication slot and pull the data from there. If you're connecting to a database, you can also consume from Kafka or through post requests against an HTTP endpoint. It depends on the use case. For dashboarding use cases or operational workloads, like you can directly query Materialize. It's just if you want to do like heavy, long-term analytical queries on top of the pre-processed outputs, that's when you would move the data out. But like it's because we pre-compute all the work, like we can support a pretty high throughput of queries hitting Materialize from clients in your backend, because there's essentially no work happening on the read path, right? Yeah.
Yeah, we did. So we definitely set out on that quest that I mentioned. Where we originally went was we'd like to build it, right? And so we wanted to keep our Postgres 16 that we had, and we said, what could we do? We were sort of used to living in this AWS RDS world of it's very, very easy. I just spin up the thing I want. I point my DBT script at that endpoint, and I'm kind of off to the races. We were looking for an incremental view manager or something that was just like on commit, refresh all tables and all views. And we did find a plugin for that. We didn't really find another company that was offering the that sort of incremental view maintenance in the same way. If you are committed to building it yourself, I think there are solutions out there. We did find a few, but we also evaluated what would it cost us to do this, to maintain this, to actually not just use RDS, but to sort of spin up an EC2 instance and then install Postgres on that so that we could have complete control over all the plugins. And then now we're managing the plugins and we're managing the versions and all that stuff. And so that was kind of our A or B. And so we went with plan A, which was Materialize, to just sort of offload it. Yep. Okay, well, thank you guys. This was a really exciting session for me, so thank you very much. And Stefan?
Yeah, thanks. And like we'll stick around if there are further questions, and thanks for attending.